So dear students, now let me discuss about Perseval's theorem. Okay. So in the last class we have discussed about Fourier sine and cosine series, and probably this is the last lecture of Fourier series, basically on the theory part only. Then I will solve some questions based on the previous year questions of IIT Jam, or sometimes the questions asked in the NetGet also. So I will discuss about the previous year questions basically from all competitive exams from these chapters. The questions are asked. Okay. And if you talk about theory part, then this is basically the last theory part of this chapter. It is the Perseval's theorem. Okay. And what is actually done in this theorem here? Actually we want to find out the average value of f of x whole square. Okay, so what we have already the Fourier series of f of x. Okay, that the Fourier series of f of x is nothing but a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx bn sin nx. So these are Fourier series. Now we are interested about the average of f of x whole square. Okay, the average of f of x whole square, f of x whole square. So we want to find out the average of this, but and in the interval minus pi to pi. Okay, so the interval is minus pi to pi. So you know that the average value of any function f of x can be written like this, that is obviously minus pi to pi f of x whole square dx divided by integration minus pi to pi dx. So this is the general expression of finding out the average value of any function. But here our goal is not only to find out the average value of the function, but we are interested to know about the average value of the function in terms of Fourier coefficients n, bn and a0. So in that case what we will do, we will just square this function f of x. Okay, we will just square this function f of x, and then we will also square the right hand side and left hand side. Then we have to take the average of for each and every term. Okay, so what you will get if you take the average of f of x, if you square this f of x, okay, then left hand side you will get this, left hand side you will get just f of x whole square, f of x whole square you will get left hand side. And in right hand side what you will get, in right hand side you will get the square of this all terms. So instead of writing down all these terms, let me tell you what are the terms that you will get separately. So you will get a0 upon 2 whole square, you will get a0 by 2 whole square, you will get this term, you will get n cos nx, n cos nx whole square, and you will get bn sin nx whole square, bn sin nx whole square. And you will get other cross terms also, where either cos nx will appear or sin nx will appear with some constant, obviously that is a0 by 2, or you will get cos nx and sin nx in multiplication form. Sorry, sin nx in multiplication form. So your right hand side will contain these terms, and your left hand side contain this term. So if you want to take the average of left hand side, that is f of x whole square, then you will have to take the average value of right hand sides also. But here in the right hand sides you will see the average value of cos square nx and sin square nx, and the average value of cos nx, sin nx, and the multiplication of these two. And always if you do the average value of this cos nx and sin nx, then you will find always the average value of sin nx and cos nx with full period will always be 0. These terms will always be 0, and obviously the multiplication of cos nx and sin nx will also be 0. Not only this, you will get the average value of cos square and sin square in x. Obviously you will get always average value of sin square in x and average value of cos square in x. You will get always half. The average value of this will always be half. So what you will get, the average value of f of x whole square. So if you want to find out the average value of f of x whole square, so what you have, you just have f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Okay. bn sin nx. So if you want to find out the average value of f of x whole square, then you have to take the average value of a0 by 2 whole square plus average value of an square cos square nx and average value of bn square sin square nx. Okay, because other terms, the average value of other terms, that is the cross terms, will be 0. Either that will be a0 an cos nx, bn a0 cos sin nx, or maybe the multiplication of these two cos nx sin nx. So all the average value of all these terms will be 0 and only the survival terms will be these, and the average value of constant is the term itself. So the average value of this will be just a0 square by 4, or you can say a0 by 2 whole square, and the average value of an square is just an square, and average value of cos square nx is half, and also the average value of sin square nx is half. Okay. So what you will get, so you will get the average value of f of x whole square. The average value of f of x whole square is this. Okay, so that is nothing but a0 square by 4 plus half into an square plus bn square. N square plus bn square. So this is actually known as the Perseval's theorem. This is known as Perseval's theorem. Perseval's theorem. And if you write the Fourier series in complex form, then you have, this is minus infinity to plus infinity cn e to the power I into nx, and in that case you will get the average value of f of x whole square will be mod cn whole square. Okay, so you will get this. So this is also the Perseval's theorem, and this is also the Perseval's theorem, but this is for when the Fourier series is expanded in terms of sine and cosine, and here in the exponential form, and this is popularly known as the complex form. Okay. But this Perseval's theorem sometimes called that completeness relation. Okay, so this is sometimes called completeness relation. Okay, so this is sometimes called completeness relation. Completeness relation. Why? Because you have f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an sin nx plus bn cos nx. Now in this expansion you will get all the terms of sine and cosine, all the basis set, and it will form a complete basis set. So there is no missing term. You cannot see here the missing term. Okay, so if you write the Fourier series of f of x something like sine 2nx and something cos 2nx, then what will happen in these terms? If you want to write the Fourier series like this, sine 2nx or cos 2nx, then you will miss the term like sin x, sin 3x, sin 5x. Okay, these terms will be missing. Here you can see if you put n is equal to 1 to infinity, then no term will be missing here. You don't miss any terms. If n is equal to 1 sin x, if 2 sin 2x, if 3 sin 3x. But if you put here n is equal to 1, you will get sin 2x directly. If you put n is equal to 2 here, you will get sin 4x. So you will miss this term sin x, sin 3x, 5x. Similarly, sin cos 4x, cos 3x, cos x. You will miss these kinds of terms. So you cannot tell in that case that this Fourier series, the terms of this Fourier series will form a complete basis. So to form a complete basis, there should be present each and every term. Okay, and if some terms are missing there, okay, then what will happen? If you talk about the complex form, then you will have that this f of x whole square, this f of x whole square mod f of x whole square average is equal to mod cn the whole square. Okay, but if there are some terms are missing on the right hand side, then what will be the relation? This will be inequality, and that will be something like f of x mod whole square average is greater than equal to cn mod square, and this is sometimes called Bessel's inequality. Bessel's inequality. Okay, so what this Perseval's theorem said, that to follow this f of x mod square is equal to mod cn whole square, that is the average value of f of x the whole square, or if mod f of x whole square is equal to mod f of x whole square average equal to a0 square by 4 plus half into an square plus bn square. Okay, so if this equality will only hold if each and every terms is present in this equation, in this expansions. That means it forms a complete basis, and that's why sometimes this Perseval's identity is known as completeness relation. That this identity tell you about the completeness of the Fourier series, that the terms involving the Fourier series form a complete basis. Okay, so that's why sometimes this Perseval's theorem is known as completeness relation. Okay, now let me show you some examples of some application of this Perseval's identity. Okay, so let me first show you a physical situation, a physical example, then I will tell you about a mathematical example also. A physical example. Okay, so in sound wave, if you talk about sound wave, this is a very good example where Fourier series used in sound wave, waves and vibration. So in sound wave, you might have known that the excess pressure, okay, excess pressure can be expanded, can be right. Okay, excess pressure can be right p of t is equal to summation n is equal to 1 to infinity pn sine 2 pi ft to n pi ft, sorry, to n pi ft. Okay, so bn is equal to sine 2 n pi ft, or sine omega t, n omega t, or n omega is equal to 2 pi f actually. Okay, so bn sine 2 n pi ft. Now if you take the average of square of this excess pressure, okay, then according to Perseval's theorem you will get this is equal to mod bn whole square, mod bn whole square, bn square. Okay, so you will get the average value of this is equal to bn square. Now what is the energy? The energy or intensity of sound wave. Okay, energy, or and there will be half also, because average value of this is half. And energy or intensity intensity of sound wave is always proportional to p of t mod square the average. Okay, so you will get proportional to pn square by 2. So from here you can find out the energy or intensity of sound wave is depend on each and every time of each and every harmonic of the sound wave. Okay, for n is equal to 1 to infinity. So the intensity of sound wave is responsible for each and every harmonics, each and every harmonic terms of the sound wave. Okay, so this is one physical application of Perseval's identity, of Perseval's theorem. You can easily find out the average value of the square of the excess pressure, and from where you can find out the energy or intensity of sound wave. So this is one of the very good example, that is the physical example of Perseval's theorem. And another example you can find from mathematical aspects, that we can sometimes find out the value of some infinite series. Okay, so we can find out some value of infinite series by using Parseval's theorem also. So now let me take an example of function f of x. Okay, f of x is equal to x in the interval -1 comma 1. Okay, now if you expand this function f of x is equal to x within this interval by using Fourier series or by using complex form, then what you will get? Okay, you will get the expansion. So please do it yourselves, because we have done many times the expansion of Fourier series. So I am taking the direct result of the expansion of f of x is equal to x, because here my aim is to show you the application of Perseval's theorem. Okay, so if you have the Fourier series of f of x, and you can expand this f of x by using the complex form. Okay, let me write down directly the result. Okay, so it will be minus I divided by pi into e to the power I pi x minus e to the power minus I pi x minus half into e to the power 2I pi x. Okay, plus half into e to the power minus 2I pi x plus 1/3 into e to the power 3I pi x minus 1/3 into e to the power minus 3I pi x. So you will get this kind of Fourier series if you expand this f of x is equal to x by using the complex form of Fourier series. Okay, now if you take the square of f of x, and if you find out the average value of f of x whole square, so what you will get? So you will get just average value of, according to the Fourier complex form of Fourier series, the Perseval's identity or theorem will be something like this: whole square average is equal to Cn mod Cn square, and that is obviously from minus infinity to plus infinity. So all the terms, the coefficients of Cn, there will be add of coefficients of all this term. Okay, so summation will always be there. N means always be, the summation will be there. Okay, so what will be the average value of f of x whole square? You will get from here within this limit, and you will get here that will be, the interval is 2, so you will get here minus 1 to plus 1, and if you get the square of this, it will be x square dx. Okay, and divided by minus 1 to 1 dx. Okay, and that will be equal to mod Cn whole square. That means each and the coefficient of each and every term will be there. Okay, so square means, and the mod square of this is 1 upon pi square will be there. Okay, and the other terms will be, from here the coefficient is 1, here also the coefficient is 1, so that will be 1 square plus 1 square, so 1 plus 1. Okay, then here you will get 1 by 4 plus 1 by 4, then you will get 1 by 9 plus 1 by 9. Okay, so these kinds of terms you will get. So in the left hand side you will get, this is half, just integration x 2. Okay, so minus 1 to 1 dx means 2, so it will be just half into integration minus 1 to 1 x square, that is x cube by 3, and this is even function, so it will be 2 into integration 0 to 1 x square dx, that means x cube by 3, and that will be 0 to 1, and here if you take common 2, so it will be 2 upon pi square, 2 upon pi square into 1 plus 1 upon 4 plus 1 upon 9 plus dot dot. Okay, so you will get this 2 will be cancelled out, and this will be 1 upon 3 is equal to 2 upon pi square into summation 1 upon n square. Okay, and n is equal to 1 to infinity. So you will get the infinite series of this. So this summation n is equal to 1 to infinity, n is equal to 1 to infinity 1 upon n square equal to, you can see, 1 upon 3 into pi square by 2, that is nothing but the pi square by 6. So we will get that n is equal to 1 to infinity 1 upon n square is equal to pi square by 6. Okay, so this is how you can find out the value of some infinite series by using the Perseval's theorem followed by Fourier series expansion. Okay, so finally what we have got, so we have got this n is equal to 1 to infinity 1 upon n square is equal to pi square by 6, that means 1 plus 1 upon 4 plus 1 upon 9, okay, plus 1 upon 16 plus 1 upon 25 dot dot after infinity will get, that is pi square upon 6. Okay, so these are the some applications of Parseval's theorem. Okay, and these are the end of this theory part of Fourier series, and from the next class I'll solve some problems based on previous year question paper. Okay, thank you.